Hello everyone, am I audible? Please reply in the chat box if I am audible. Okay. So let's begin with the session. Hello everyone, I am welcome to Geeks for Geeks. I am Ayush Shukla here with the post contest analysis of Buy Wizard contest. So I will be discussing the solutions of the uh, coding and quiz both. So I will be starting the session within 2 more minutes. So be with me and we'll be discussing all the solutions. So let's begin with the session. Yeah, Harsh, what are the prices? As per prices, they are already mentioned in the instruction section that you will receive swag kit and goodies, and you will also top 100 students will receive letter of recommendation from the CEO of GFG. So that will help you a lot. So I will be charting the session and I will be taking the doubts at the end of the session. Okay, so let's begin with this quiz section. Okay, so we'll be beginning with the very first question. So the very first question is this. Uh, Consider the usual algorithm for determining whether a sequence of parentheses is balanced or not. So the maximum number of parentheses that appear on the stack at any one time when the algorithm analyzes. So basically in this question we have to find how many maximum number of brackets will be there in the stack while determining the balanced parentheses. So for this question we will be using a stack. So let me maintain a stack and we will be pushing the open brackets in the stack, and whenever we encounter the close bracket we'll be popping out the respective open bracket. So first we will be pushing the close bracket, second time we will be pushing close bracket, then we will be popping it out because we have close bracket, then we will be again pushing the open bracket. Next we will be pushing the open bracket, then we will be popping it out. Next time we'll be popping it out, and we will be maintaining also the how many number of uh, open brackets are there in the stack at any point of time. So till this point we have only two open brackets, that's why we'll be maintaining that. So maximum till now is 2, so I will be writing maximum 2. So once we will be encountering the maximum we will be, so we have maintained till this point of time. Now this we have one next second, and now when we will be encountering one more close open bracket. Now we'll be encountering the close bracket, so we'll be popping it out. So maximum till this point of time is 3. Now we'll be popping all the three brackets, and the stack is empty. So maximum in this question will be equals to 3. So we'll be marking it as 3. So we'll be moving to the next question. I think there is a bit lag on the session. Yeah. So our second question is, what is the disadvantages of implementing tree using normal arrays? So let me read out the options. Difficulty in knowing the children of a node. No, there is not a difficulty in knowing the children of a node, because if we have the array, uh, implementing with normal arrays, we have to implement tree. So we can find the children using uh, 2 into I plus 1, or 2 into I plus 2. So we can easily find this. Second option is difficulty in finding the parent of the node. No, we can also find the parent if we know the child. Suppose child is here, so we can find the parent using the dividing the by 2 and finding the floor value of that. So we can easily find the parent. Next, have to know the maximum number of nodes before possible before the creation of trees. Yeah, this is option, because in maintaining the array we need to know how many number of nodes will be there in the tree. So we have to maintain that. Next question is third question. Which of the following data structure can be used to implement different type of queues? So we can use stack also to maintain a queue. We can either make it suppose queue has a property that it will be a FIFO, that is first in, that will and first out. So the element inserted first will be inserted out, deleted first. So suppose we have inserted 3, then 4, then 5, then 6. So the 3 is inserted first, so 3 will be deleted also. So this is a property of queue. So we can make this property using stack also, but we have to make certain options costly. That is, either we have to make the enqueue operation costly, or either we have to make the dequeue operation. That is, we make the terms that enqueue is the pushing enqueue is the insertion of the element in the queue, and dequeue is the element deletion of element in the from the queue. So we have these two options. So here, so we can maintain this. Suppose first time we have inserted 3, and next time we have 4. So we'll be just inserting in a O of one manner. And when we have to delete, then we have to maintain a second array, a second stack, and we have to push all the elements in the stack, um, other than the last element, till it does not have the last element. So these will be popped out, and we will be printing this. Then we will be again pushing this into the stack, so it will be taking O of n time, that is deletion time. So we can use a stack. Similarly, we can use arrays also. We can use heap, we can use any of these. So we have the option all of the above in this question. That is third question. So fourth question is, the elements of the linked list are sorted. So in this sorry, the elements of the linked list are stored. So uh, it can't be stored in a structure because a linked list also has its defined structure. And so we can also implement a linked list using array, because it's obvious we are implementing the linked list and we don't need to maintain the continuous memory location, so that we can use array. So it's a similar option as here, the continuous memory allocation. We are using linked list, that's why, because we don't want to maintain the continuous memory locations. So we can store the linked list elements anywhere where the computer has a space for them, and we will be having a pointer that will be pointing to the next memory location, to the next node. So we can have that space optimization in linked list. So we will be moving next to the for fifth question. So it is the which of the following sorting algorithm provides highest time complexity in the worst case scenario. So we have to check which algorithm provides the highest worst case time complexity. So in case of merge sort, it will be merge sort, uh, merge sort. Its worst case complexity is also O of n log n. Worst case and the best case both are O of log n. And bucket sort, it is O of m plus n, that is O of m plus 1. And radix sort, uh, it is equal to O of n into d, that is d is the number of digits that the number have. So this is radix sort. And in selection sort, the worst case selection sort, the worst case time complexity will be equal to O of n square, because we have to maintain two loops here. So that's why the worst case time complexity will be maximum of selection sort. So next we will be moving to the sixth question, which is we have to show the output of the code. So initially we have I equals to 0 and n equals to 4 and sum equals to 0. Next we have array given, that is 65, 45, 10 and 125. So for this I will be having and there is one loop that is running from 0 to 3 until I less than 3, and we have to add the number. So simply we have to run for the for loop from 0, 1 and 2. So we have to just add these numbers from 0 to 2 array. So we are given array as array equals to 65, 45, 10 and 125. 125. So it should we are running for loop from 0, 1, 0 to 2. So it will be adding these three elements. So it will be having 65. Some will be storing 65 plus 45 plus 10. So it will be equal to 65 plus 45, that is 110, plus 10, that is equal to 120. So the correct answer is 120. Okay, so we'll be moving to the next question. What is the time complexity of function? Okay, so we are given here the function and we have to return the time complexity of the function. So since there are two loops running, that is the ith loop that is running from I equals to 0 till I less than n plus 2, and it is incremented by 1. And the second loop is j equals to I till j greater than 0, j minus minus. So there are two loops running in parallel, so it will be clearly O of n square. So that's what we have to return here. Next question is binary search is feasible to implement in a linked list. No, I think it is not feasible to implement in a linked list, because here we don't have that sorted kind of thing, and we can't have the indexing. So binary search is not feasible in the linked list. So for this question, it should have answer false. If we want to next question is, if we want to store the address of the head node in the next pointer of the last node, then which type of linked list is okay. So basically in this question we are given a scenario that we have the linked list, and suppose it is like this. Suppose we have the linked list is, so if we want to store the head node in the next pointer of the last node, suppose this is the last node and we have to store the address of the head node in this pointer. So it is a kind of circular linked list in which there is the last pointer, last node is also containing the reference to the head node. So it is a circular linked list. So this is the concept of other than that, single linked list doesn't have the concept of last pointer having the reference to the first point, hash list no, and double linked list no. It is double linked list is a very similar to single linked list, but it only have the two pointers, that is previous and next both. That's why it is a double linked list. So we'll be moving to next question. So our next question is this: we are given a for loop from I equals to 1 till I less than n, and it is incremented using I equals to I into 2. So we have to return. Okay, we have to find the time complexity. So suppose at some point of time, after some time iteration, that is k iterations, the conditions fails, that is 2 की power, suppose 2 की power I is incremented in the power of 2. So firstly it is 2 की power 1, next time 2 power 2, next time 2 power 3, and further at after 2 की power k operations the conditions fails, suppose that is 2 की power a k greater than or equal to n. So greater than n, okay, so greater than n. So for this point we'll be fine having the false condition, and we will be running out of loop. So for this we will be finding the time complexity using we will be taking log both sides. So log of 2 की power k greater than log of n. So it will be k log 2 greater than log of n. So here, and sorry, k will be simply equals to log of n on the base 2. So that's what the answer here of log n. Next question is 11th. Memory allocation will be maximum in which type of linked list with equal number of nodes. So there are options at a single linked list, circular linked list, double linked list, and always takes a similar space. No. So in this case, in single linked list, it will require only the data node and the next pointer. Data node and the next pointer. So this will be a case of single linked list. In circular linked list, we just need one more pointer, that is this. So it will not require the max memory. In double linked list, we will be maintaining three things, that is data, previous pointer, and the next pointer. And similarly here, on data node, then previous pointer, next pointer. So it will be requiring more memory because it have to maintain both the previous and the next pointer. So that's why it has to take max memory. So our answer will be double linked list. Next question, that is we have uh, x equals to 16 and y equals to 8. Initially x equals to 16 and y equals to 8. And next we have to find given x divided by y. so it will be 16 divided by 8 equals to 2. Next z will be equals to y means here 8. It is left shifted by 2. So left shift means multiplying by 2, so it is left shifted by 2, so 8 into 2 into 2, so it will be equals to clearly 32. So we have to print z, so it will be equal to 32. Left shift operation here means multiplication. So next question is what will be output of the following pseudocode. So we are given x equals to 2 and y equals to 1 and z equals to 5. So this is the given scenario, and we are given a equals to x and y. So x will be here 2 and y will be 1. So 2 and 1 or z plus plus, that will be equals to 6. So we have to do this operation. So clearly 2 and 1 will be equals to 1, and with the OR operations, so a will be clearly equal to 1 in this case, and we have to, since we have to return the answer, so in this case it will be equals to 1 a, and x will be equals to 2, y will be 1, and z will be equals to 6. So the correct option is this first option, 1216. So the next question, that is question number 14, is we have to output the following pseudocode. So in this case we are given a equals to 10, b equals to 7, and c equals to minus 13. So we have to do certain number of operations, and after that we have to print abc. So a equals to b plus c, so 7 minus 13 equals to minus 6, a equals to minus 6. Then c will be equals to a plus b, so a will be minus 6 plus b equals to 7. So c till this point is 1. Next c equals to c plus a, so c is 1 and a is minus 6. So this point c will be equals to minus 5, and now c equals to b plus c, so b is 7 and c is minus 5. So till this point c is equal to 2. Now b equals to b minus c, so here b is 7 and minus of c is equal to 2, so b will be equal to 5. So b is 5, c is 2, and a equals to minus 6. So let me check the options, that is minus 6, 5 and 2. So this is the option that is true. So we'll be moving to the next question. So this is the question number 15, and here we have the to set the value as initially value is having the value 1 and n equals to 25 we are given. Then we will be running a while loop till the value is less than or equal to n, till value is less than or equal to n. So we'll be running a while loop. Next we will be having a value equals to value into value equals to value left shift by 1. So left shift by 1 means multiplying by 2, and at the end we will have to print the print the answer as value. So firstly initially the value is equal to 1. First left shift operation will give 2, second time it will be 4, next time multiplying by 2 8, next multiplying by 2 it will be 16, and next time 16 is less than or equal to 25, so we'll be next moving in the while loop again. Next time it will be 32, and now 32 is not less than or equal to 25, so we'll be having this as the final answer. So we have to just return the final answer, that is 32. So this is the 16 number question, and we have to print the whatever k is required. So let me run the code here. Initially we have the integer ijkn, and j equals to 2 and k equals to 2. Then for loop will be there, that is from I equals to 1 till I less than equal to 3 I plus plus, and we'll be printing k each time. So first time we'll be printing 2, then j will be incremented, so j will be incremented by 2. So initially j will be 4, so this time j equals to 4, and k equals to k plus j. K is 2 plus j, that is 4, so k equals to 6. Next time k will be printed, k equals to 6, so 6 will be printed, and after that again j will be incremented by 2, so j will become 6 and k will become 6, and that is initially 6 and j, so it will be equals to 12. Next time it will be printed and it will be equals to 12, and after that it will be incremented, but we did not to think about that, and we just have to write it for 3 times, so we have got the answer, that is 2, 6 and 12. So yeah, that's find the output of the following pseudocode. So integer c comma d. Aman, which question are you talking of? Can you reply the question number? Yeah. So we'll be moving to the next question, that is question number 17, and the integer c comma d set c equals to 20 and d equals to 15. After that, so in this question, uh, Aman, can you please reply which question you are talking of? Okay, you are asking for the 13th question. Okay, let me check there. So, yeah, you have asked that is answer should be D 1215. No, it should not be D because Z is incremented. D is already incremented, so answer should be A. Yeah. Uh, So I think there might be a mistake there. So we'll be moving to the our questions. That is question number will be, I think 17. Yeah, we were at 17. So we have integer set c equals to 20 and d equals to 15. initially. So d equals to 20, sorry, c equals to 20 and d equals to 15, and next we will be having d equals to c minus 1, that is 20 minus 1 equals to 19. So we have d's. Next print c, so we'll be printing c, that is 20. Next uh, c equals to d plus, that is d is 19 plus c minus 2. So c is 20 minus 2, that is 18. So 19 plus 18, that will be equals to 37. So if c is less than 55, so c is less than 55 clearly, so we have to go to line and print, we have to again c, so it will be equals to 37. So the correct option is 20, 37 and 54. So this will be our option. Which of the following is true about linked list? We are doing the question number 18. So yeah, binary search and linear search have similar time complexity. Yes, they have similar time complexity because here's no concept of binary search or linear search. Everything will be almost same, and implicit sorting can be done. Yeah, it can also be done. Random access is not allowed in typical implementation. Yeah, because random access can't be done because we have the only pointer reference and we can't use index here, so random access is not allowed. So all of the above options are correct. That's why we'll be moving to the next question. And the 19th question, that is right, we have to write the level ladder traversal. So level ladder traversal is pretty simple, that we have to print that. So let me explain it here. It is pretty simple, we have to write in this order, that is what is coming here. So this is the level order traversal, so I will be writing in this order only. So so the level order traversal will be clearly 2, then 11, then 3, then 1, then 15, then 7, 7, 12, 8, 6, 12 and 4. So this will be a level order traversal. Let me check the options. That is 2, 11, 2, 11, 3, 1, 5, 1, 15, 7. So the correct option is third. So we have to move to the next question. So let me erase this. Okay. So our next question is, what does left shift and right shift operator does respectively? So I have already mentioned in the earlier question, that is left shift uh, is represented using this, and it means multiply by 2, that is multiply by 2. And right shift operator is represented using this and means divide by 2. So the correct option is multiply by 2 divide by 2. So this is all about the quiz here, and I have discussed all the questions. So is there an issue in the 13th question? Everyone is asking, so let me check once again. uh, I think option it should be A option, because that is incremented, so there's no point that it should be 1215. 5216. No, there is no sense about that. It should not have. It should be option A from my side, and I'll check once again after the completion of the video. So if there is any correction, I will be marking that in the comment section. From my side, it is the first option, that is A option. So next we will be moving to the coding problems. So in this problem, the very first problem, that is game of 2. So in this problem, basically we are given Alex as the topper of the class. Let me read the question first, then I will be explaining the question. So Alex is the topper of the class. Once his teacher challenged him to solve the problem. He gave a number n to Alex and asked Alex to find the closest power of 2 near to the number. Okay. So the question here is, we are given a number. Suppose the number is 11, and so we have to find the closest number nearer to this number, such that it is a power of 2. So power of 2 means, so it have to, clearly 11 is not a number that is power of 2, so we have two options, that is 8 and 16. So it is more nearer to the 11, so we'll be returning 8, because 8 is 2 to the power 3 and 16 is 2 to the power 4. So in this case we'll be returning 8. The number which is more nearer to the given number will be written as the answer, and if both are them are at equal distance, then the larger number will be returning. Here it is written, that is, otherwise return the minimum class. If the power of 2 is less than the same distance, then the power of 2 greater than the number, return the power of 2 greater than that number. So we'll be returning the largest number in case of equal distances. And suppose we are given the number as 7, so we have two closest power of 2, that is 4 and 8, that is 2 to the power 2 and 2 to the power 3. But it is distance of 8 and 7 is 1 and 4 and 7 is 3, so it is closer to the number 7, that's why we'll be returning answer as 8. So the logic is very pretty simple. So for this question, we can have the approach that firstly, we whatever number we are given, that is n, we have to find the log of that number, log on the base 2, that will be giving, suppose we are given the number as 11, so we'll be finding the log 2 on the base 11, log of 11 on the base 2, so it will be equal to clearly 3 point something. So p, since we will be maintaining p equals to n type, so it will be having 3, so it will be p will be equal to 3. Next we will be checking for the two numbers, that is, uh, first we will be that is the smaller number, that is power, will be using the power function, and that is 2 to the power p, we will be checking for this, and second will be uh, power 2 to the power p plus 1, that is for the large more value. So we'll be finding these two, and if first double equals to second means both are at equal distances, so we'll be returning the second. So we'll be returning second in that case. And if this is the case, else if the case will be first will be more closer to the second, more closer to the, what we can say, that the number, then first is more closer, then we will be returning first in that case, and else we'll be returning the second, returning second. So I have written the code. I will be explaining better there. So whatever I have told that firstly we will be in getting P as uh, that log of n on the base 2, and it will be of type int. After that we will be checking if the same number that we have got, that is 2 to the power p, if double equals to n, so we will be returning that number only. And if this is not the case, that is suppose we are given the number as 8, and after finding the log of 8 on the base 2 we'll be getting 3, and next when we will be finding 2 to the power 3, it will be equal to 8. So clearly it will be equal to the number, so we will be just returning that number because the distance of the number with this number what we have found is equal to 0. That's why we will be returning that number. Else this is not the case, then we will be finding the absolute distance from n minus, that is the number that, and first case will be 2 to the power of p for the lesser number we'll be checking, and second for the higher number, that is 2 to the power p plus 1. Suppose we are given 11, so p is equals to 3, so will be first will be equals to n, that is 11 minus 2 to the power 3, that will be 8, so it will be 3, and second will be 11 minus absolute, will be taking the absolute value, that's why, so 11 minus 2 to the power 4, that is 16, so it will be equals to 5. So clearly first is more closer, so we will be returning answer equals to 8. So first we will be checking if it is first and second are equal at equal distances. So at equal distances, so we will be returning the second, that is higher number. Else first is like less than second, means first is more closer to the n, so we will be returning the first. Else uh, will be returning the higher number, that is 2 to the power p plus 1. So the time complexity is very obvious, that is it is of the power, whatever the power function is taking, it is of time complexity that. So let's try to compile this question. Okay, yeah, compilation is completed and we have the expected output same as on the current output. So let's submit it and check whether it is okay or not. Yeah, it is. Yeah, it is okay. It is not giving the points because I've already attempted this question, so it is 100% accuracy there. And yeah, this is it for this question. Next, we will be moving to the next question, that is birthday party. So in this question, let me read out the question first. Uh, yeah, Ashu, I will be looking the fifth question after this question. So be with there. I will be checking there. Okay. So Alex hosted a birthday party in his house. He invited an of his friends to the party. He made two type of sandwiches for the party referred by the number zero, and so basically he have two type of sandwiches. One is circular and other is square, I think. Yeah. So square sandwich is represented by 0 and circular will be 1, and there are n friends and each of them have their preferences, so we have to serve according to their preferences. So and there is a queue of the friends, so we can't serve any of the other member other than queue because we have to maintain the order. So basically in this question we will be given friends and sandwiches. So suppose friends are given 1 1 0 and 0, and sandwiches are 0 1 0 1. So we have to maintain the order of the sandwiches. because once they are served, because they are in a queue, so and our friends can move if it is not their sandwich, they can move to the backside of the queue and other will be getting the served. So in this case, one the friend one will be demanding friend one will be demanding one, but it is zero in the sandwich, so he will be moving to the backside and the queue will be on this. Next, one there will be one again, so it will be also moving the backside, and the queue is now 0011. Now this friend will be demanding the zero queue, so we have to serve them, and one friend is served. Next, this is demanding zero, and this is demanding zero, and we have one, so we will be moving backside, and it will be this. Uh, this array, because we have already served this, so we'll be having uh, it cut it down. Next, the friend is demanding one, and the sandwich is also one, so we'll be serving this, and we have two friends now served, that is 1 plus 1, two friends served. Now we'll be removing these also. Now this one is demanding the sandwich one, and there is zero, so this will be moving backwards of the queue, and this here will be it is queue. So now the queue is just 0 1, and the sandwiches are 0 and 1, so 0 will be served, and we have the next person served. After that 1 and 1, so next person is also served. In this case all the four persons will be served. Taking the next case, in this case we will be having friends, that is friends array 1 1 1 0 0 and 1, and the sandwiches array is 1 0 0 0 1 1. Okay, so in this case I will be serving uh, the 1 and 1, though 1 is served, and then there is no one, so we'll be moving these two ones back of the queue, that is 1 and 1, so these are removed. Now the queue is this. After this 0 will be served, 0 will be served, so one more will be served, 0 and 0, so one more will be served. After this